Hello everyone. So today our topic was OOPS technique for model life cycle in Python. So the OOPS I stand for Object Oriented Programming Systems. Technique can be applied efficiently in the model life cycle to manage the structure, scalability, and maintainability of machine learning models. Like in OOPS, there are many concepts like encapsulations, date abstractions, inheritance, and polymorphism. So we will see how we will write code for this one. So for first we will write. So first we will write for a encapsulation. So for that, first we have to create a class. So in this function, we'll take argument, which is first one is self. After that, we take name, algorithms, and hyperparameters, which is required for our model. So after that, we will define all the things like the name was model. And after that, we have to define our algorithm, which is algorithm. And after that, we have to define hyperparameter, which we will define as a hyperparameter. So this is example of how we can use OOPS for model building, and it's defined the attributes for data preprocessing, feature engineering, training, and evaluation in separate method within the same class or child. After that, we will see for data handling in which we have abstraction. So in this, we will create an abstract class to handle the various data preprocessing techniques, ensuring consistency and reusability. So for this, for first we have to import some, and we will import some classes. Like for me, it's I create one file which is ABC. From there, I will import some function which is ABC and abstract method. And after that, I will create a class name as data preprocess data preprocessing, in which we pass argument which is ABC, and we will define this class as an abstract method. After that, we create another function which is data preprocessing, in which we have self. In this, we will just only pass this value. And after that, we again create a new class. The class name was normalizer, and in this we will pass this data preprocessing. In this, we will create a function which is named as data preprocessing. In this, we print data is normalized. So this is example of like abstraction, how we will use abstraction in uh, model building and in machine learning. After that, we will see the example of how we can do inheritance. So in this inheritance, we create a base class from a common training process and inherit the specific algorithm. So for this, we will create a class which is named as base model, in which we will define a function name as train, in which we will pass self, and data. So we will print this model is trained, or maybe if some issue will came, we will just for raise, we will use non-implemented error. After that, we will create another class, which is like for now I'm creating a class which is linear regression model, in which we pass the base class. And in this, we create a function which is train, in which we'll pass data. And in this, we will just simply print like linear regression model is trained. And we also return this linear regression model is trained. Or maybe if we don't want to print anything, just we can use a pass. After that, we will see model evaluation. In model evaluation, we have polymorphism. So use of a polymorphism for evaluation functions allow flexibility in evaluating different metrics based on the model type. So in this, we will create a class name as evaluation. So we just simply this pass, we use just pass. We don't want to print anything. And again, we create one class, which is RMSE, in which we will pass evaluation. And after that, we create a function, which is evaluate, in which we pass first self, and after that, we will pass model. And after that, we will pass test data. And here we will just return like root means squared error. We will just do like this. After that, we create a new class, which is named as class accuracy, in which we will pass evaluation. In this, we will create one function which is named as evaluate. In this, we will pass argument, which is model and test data. And in this, we just simply return accuracy. After that, we have like our fifth point, which is version control and model management. In this, we can use encapsulation for storing and retrieving model metadata, like such as training time and parameters and performance metrics. So for this, we can write a function, which is not a function, which is class, right? Like model manager. So in this, we just define self dot model, which is equals to none, not none, which is after that we will After that, we will define another function, which is save model. Save model in which we pass first self, and after that we will pass our model, and we will just declare self dot model dot append, in which we will pass model, and after that we will create another new function, which is uh, list model. In this we will just simply return our self dot models, self dot model. So this is example of how we can use encapsulation to storing and retrieving the model metadata, like training time and parameters and performance metrics. And our sixth point is like deployment. Our sixth point is deployment and monitoring. So like encapsulation and abstraction can be used for building a deployment pipeline, uh, creating a deployment class to handle operations like model serializations like pickle or joblib, integration with API and serving. After that, polymorphism help in switching between different deployment strategies like cloud-based or edge devices. The benefit of using OOPS for model lifecycle is like for modularity, we can break down the lifecycle into manageable components. Reusability, we can reuse existing class for simpler, similar projects. And third one is scalability, easily extended class for a new functionalities. And the fourth one is maintainability. So easier debugging and update due to structures coding. Like by applying OOPS techniques, we can standardize the development process, making it more robust and easier to manage in a large scale machine learning projects. So like in use cases, for use cases like modular representation of models, so we can define a base class for a model that can be extended for a specific algorithm. Like this allow consistent handling of all models in respective of the algorithm. Like for this we can create one base class in which we can define a function which is init function. We can pass name. So we can define some name. After that, we can create one function which is pre-processing, in which we will pass data. And if some error will come, we can write a code for error, which is raise non-implemented error. In this, we can pass like pre-processing logic must be implemented. Like after that, we will create more functions like for training and evaluating. For data preprocessing, we like abstraction for multiple preprocessing techniques. So abstraction based class allow you to handle different type of a data, like text, image, tabular data with a specific child class. So for this, previously, we will write one example from here. So we just remove this code, and after that we can write, we will create one class which is named as text preprocessing, and in which we will pass data preprocessing. So after that, we will create a function which is named as preprocess, in which we will pass self and our data. So simply here we will return return a list which is sentence dot lower or sentence which is in data. So it will be after that like this is for a text. If we want to create for a image, we can simply create for image. In this we will pass self and data. After that we will return data dot resize, in which we want our data into 224 comma 224 format. So this first one is the example how we will return, like with the help of abstraction, how we will can do like return text pre-processing and image pre-processing. So for feature engineering, like encapsulation feature engineering steps such as like scaling, encoding, and feature selection into reusable classes. So for this, like if we will write code for, so we will create a class which is named as feature engineering. Feature engineer. In this, we will create a function which is our init function. In this, we will pass self. After that, we will pass scalar. After that, we will pass encoder. So in this, we will define like what is our scalar and what is our encoder. After that, we will create another function which is transform. In this, we will pass self and our data. So in this, we will scale data, which is our scale self dot scalar dot fit transform. In this, we have argument, which is our data. So for the same thing, we will do for encoding data also. In this, we will use self dot encoder dot fit transform data. After that, we will return our encoded data. So this is like example how we can use encapsulation for feature transformation. After that, for model training, like we can use inheritance for extending training functionalities, like creating a base training class that handle common tasks such as splitting data or logging metrics, and inherit and extend the functionality for the specific algorithm. So for this, we can create a class which is trainer. So we will create a function which is split data, in which we will pass self and our data. We just simply pass this. We don't want to do anything. After, after that, we will create one function which is log matrix. in which we will pass self and matrix. And we also just we print here, we will print matrices. And after that we will create a class which is svmt trainer. In this we will pass model trainer. In this we'll create a function which is named as train. In this we will pass self and our data. So for this we will do self dot split data, and after that we will do self dot log matrix. And we can just, like, if we want to print, we can print. We can use for accuracy, which is 0.95. And this is the example like how we can use inheritance for model training. And after that, we have model evaluation. In this, we can use polymorphism for multiple metrics, like define a base evaluation class with a specific matrix implemented in a subclass. And our sixth point was like model precedence. So in this, we can use encapsulation for saving and loading models. So like encapsulation model persists logic using pickle or joblib into a dedicated class. And our seventh and the last point is deployment. So in this, we can use abstract class for deployment strategies, like abstract deployment method for serving models in a different environment like REST API, cloud, and edge. And our eighth point was monitoring and maintenance. So in this, we will use encapsulation for tracking and alerts. So encapsulate monitoring logic to track predictions, error, and drift. So like for benefit in last, we will see like what is the benefits of OOPS in model lifecycle. The first one is code reusability. So classes and method can be reused across projects. And after that, second point was maintainability. So like modular and organized code, simplify debugging and enhancement. Our third point was extendability, like new functionality can be added easily by extending the existing class. And the fourth point was abstraction. So the complex operations are hidden and make it easier for team members to use the system without understanding every detail. And our fifth and last point was scalability. So efficiently handling the complexities of a large project. So using OOPS principle, ensuring a clean, modular, and scalable approach to implementing a robust machine learning pipeline. So these are all the example how we can implement OOPS concept in the machine learning projects or maybe pipeline. So that's all from my side.